Now let us look at Rapid Spanning Tree 802.1W in a bit more detail. Rapid Spanning Tree is backwards compatible with 802.1D, which is covered in the Spanning Tree presentation. However, in Rapid Spanning Tree, the convergence is a lot faster because the switches communicate interactive. You can designate ports as edge ports inside configuration, and they don't participate in building the spanning tree. They transition from disabled straight into forwarding. As soon as something is plugged into, they move straight into forwarding. However, if a BPDU, if a bridge protocol data unit is received on an edge port, it becomes a non-edge port to prevent loops, so that spanning tree is negotiated with a switch that has been plugged into an edge port. So Rapid Spanning Tree has some port roles. The root port is the same as 802.1D, the traditional spanning tree. The alternate port is a port with an alternative path to the root. So each switch, each bridge will pick the root port and a second one, an alternate port. Then for each segment, you have a designated port, which is the same as 802.1D. This is the port that forwards traffic on behalf of that segment. And then you have a backup port, which will be a redundant path for that segment. For each segment, you pick one as the designated and the other one as the backup. The synchronization process uses a handshake method. So the first step is the same. The switches need to select the root bridge, and the election process is the same. All of them say I'm the root. But once the root is selected, now the topology is built in cascades, where each switch proposes to be the designated bridge for each point-to-point link. And while this happens, the downstream link switch, the switches downstream are in blocking state on the links. So as soon as they receive a PDU negotiating the designated bridge, then they transition from blocking to forwarding as the negotiation happens. So let us look at this in a set of diagrams. In this network, we have a root at the top, we have two switches, and then two more switches at the bottom. All of these will be in blocking because they are waiting for the handshake. So the root sends a designated port proposal to the root port of the other switch, which sends an agreement. Then it will do that to the other switch on this other side. Note that for any particular switch, it can do this proposal simultaneously on the different ports. So the switch on the left that now knows what the designated port is for its root port will now send a designated port proposal into the root port, and the moment the switch receives this packet, it sends back an agreement. Same thing on this side, you send a proposal and you get an agreement back. So this is a lot faster than waiting for timeouts and for the different switches to kind of agree on which one is the designated port.